Okay, so now let's add two vectors. If you're given a vector A, say magnitude 5, theta is equal to 30, and you're given a vector B, magnitude 2, and direction 180 degree. Well, the most natural way of doing it, if we see this for the first time, is to say, well, I'm just gonna add the magnitude together, and I'm going to add the direction together. I'm done, pal. No, cannot. So please don't. There is no way you can add two vectors if they're given to you under this form. The only way is to transform their notation into the component notation, which is the one that we've just seen. Add them up from the component notation, and then you can rewrite them under this form. So let's practice this and see how it goes. Again, I'm assuming that all those directions are being given from the positive x going counterclockwise, so right away I know that I can write my vector A as 5 cosine 30 plus 5 sine 30, and similarly I can write my vector B as 2. Now cosine 180, I might as well, okay, let's write it up. Cosine 180 plus 2 sine 180. Okay, so far so good. Now, I know my basic trig. I would suggest you memorize those also. Make sure you know the sine of a cosine of 0. Make sure you know the sine of and the cosine of 30 degree, of 45 degree, and 60 degree, as well as 90. I have those 5 angles memorized, because once you know those 5, then you can deduce easily the sine of or the cosine of, say, 135. Because 135 is 90 plus 45, which is the exact symmetry of 45. So their sine will be the same, but their cosine will be opposite magnitude. So you can deduce like 15, almost 15 or 20 angles by just knowing 5. So please, if you have the chance, memorize those. So cosine 30 is square root of 3 over 2. Sine 30 is 1/2. Similarly, cosine of 180 is -1. And sine of 180 is 0. Okay. So I have written my vectors in component notation. If I want to add them up, all I have to do is add all the i's together and add all the j's together. That's simple. So the very important thing is that you only want to add the like terms. So you cannot add an I with a J and a J with a K or a K with a T, whatever. You have to add all the I's together, all the J's together, all the K together, all the times together. So in this case, if I called and I define vector C as A plus B, then vector C will be 5 square root of 3 over 2 minus 2 plus 5/2 plus 0j. And this is my vector C. Okay? Now, if I would like to write my vector C not under a component notation, but on the same style as the vector that was given to me, then all I need to do is use the Pythagorean theorem backwards. Because remember that if you, let me go back to my, there. If you know this guy and you know this guy, then you can deduce this guy and this guy. So in your case, I just have Cx and Cy. Cy is this and Cx acts like this guy. And I want to express the magnitude of my vector C and its direction. So really, I want A and theta from B and C. So this one will give me the theta. I can use Cy and Cx. That will give me theta. And then I can use Cx and Cy to give me the magnitude of C. So as I go back to our example, if I want the magnitude c, all I need to do is take my x component, cx, 5 square root of 3 over 2 minus 2. I'm going to square this guy, and I'm going to add the j component, 5 half. I'm going to take the square root of the whole thing, and this will give me the magnitude. And as I take the square root, I don't have to worry about both solutions, negative and positive, because I'm dealing with vectors, and the length of a vector cannot be negative. It has to be positive. So you only keep the positive solution. Then if you want to figure out the direction of the vector, then all you have to do is take the arctangent of the y component. And I'm not going to write it here because I'm running out of space. cy, which is this guy, and cx, this guy. Okay? So it's pretty straightforward. It's all application of the Pythagorean theorem. Now there is a little trick among this little bugger. Theta. Let's say you have a vector A that you want to express again as its... Whoa. What happened? Sorry. A say as minus I minus 3j. Okay, and you want to express this vector as its magnitude and its direction. You can get the magnitude easily, no problem. It's going to be minus 1 squared plus minus 3 squared, so it's 1 plus 9, that's 10, so magnitude is square of 10. For its direction though, you're going to use a calculator, and most likely you're going to do tangent of the y over the x. In this case is 3. So right away we lose the information about the negative signs. So as you plug this in your calculator, let me try it out. You're going to get 71. Now if you report to me that theta A is 71, then obviously I'm not going to be happy, because I will assume that if you don't specify anything, sig figures, no. I never can remember those stupid rules about sig figures, so I won't expect you to do it either. All I'm asking is that you use common sense. If you're being given values with 2 or 3 sig figures, then give me roughly the same number. Okay. Yeah, no need. So let's say you're given forces like 5 Newton, 10 Newton, and you add those forces and you end up with 7.2. 7.2 is fine. The best would be to give me 1 sig fig higher than was given to you. But if you're given vectors as 5 and 12, and you end up, adding up together, and you end up with a magnitude of 5.237259, please don't do that. Please don't give me 10 decimal points. Okay, so use the common sense. Roughly the same number of sig figures as the component that there's given to you. So if all the magnitude are given to you in 3 sig figures, then give me 3 or 4. Okay. For the course, I really don't care. For labs, you have to be more careful. But for the course, as I do lecture, usually, let's say for G, which is 9.81, I usually use 10. And the only reason I'm doing this is because it's easier for me to do math in my head. Because I'm lazy, I never have a calculator. So don't worry too much about exact numbers. During test, I will always look at how you get your answers, not the answer itself. I don't care about the answer, but I do care about how you got it. So if I see an answer and it's correct, but I have no idea how you got it, you might not get the points. But if I see and understand your reasoning, and I see that you're using, scientific method and logical reasoning, then you will get partial credits, even if you goof by plugging numbers in the calculator. So I would suggest in most tests, please do everything analytically, and only plug numbers at the end. I'm perfectly fine with this. To the extreme, if you do everything analytically and is correct, and you end up plugging numbers and you goof plugging numbers, I will still give you perfect points. Okay? So I'm not picky about sig figs and numbers in general. Okay, so obviously 71 is not good, because if you write 71, I will assume that you measure it from the positive x going counterclockwise. And by just looking at this vector, we know it's not true. The I component is negative, and the j component is negative, which tell us right away that this vector is in the third quadrant. Our vector is somewhere over here. So now where's 71? This vector can be going down or more left. Now all you have to do is look at the magnitude. Look at the magnitude of x, minus 1. So we're going to go roughly 1. Look at the magnitude of j. Magnitude of j is obviously much bigger than I. So you know that the vector is going to be closer to the y-axis. So now if the calculator is giving you 71, then you know right away with no ambiguity that 71 is this one. Therefore you know that as you give me your answer, you will give me 71 plus 180. Okay? If the x component was bigger than the y component, and you still got 71, then you know for sure that 71 is this one. Okay? So when you do this arctangent, you lose information. Added to the fact that the calculator can never give you an angle outside the range between 0 and 90 degrees, you really need to think about where this angle is. So I would suggest to first check the sign of your component. By checking the signs of each of your component in 2 dimension, you will get a feel about in which quadrant your vector is pointing at. And then by comparing the magnitude of each, you will be able to figure out if your angle is the angle between your vector and the x-axis,